Hello, everybody, and welcome to this Cloud Lunch and Learn session here today. Thank you for attending or even watching the YouTube recording. Welcome, and thank you for supporting Cloud Lunch and Learn. Today, we have a great session on generative feedback loops and automation in action. So looking forward to seeing this. We've got Bober here, and to give you a great interactive session. So I look forward to seeing what he has in store for you, and enjoy the session. And with that, I will turn it over to you, Bober.
Yeah, thanks so much. Hi, everyone. I'm super excited. I think this is a great opportunity to get to know about these amazing topics, because as we all know, the AI topic is quite important. It's becoming important for every single life. So today's topic is also quite relevant to AI. We're going to cover, especially if you're building AI applications, using different tools, technologies, and applying a different approach methodologies. This is a session for you. We're gonna cover a bit, retrieval augmented generation, shortly RAG we call it, because it became mainstream for GenAI use cases recently. And today's new approach I'm gonna introduce is called Generative Feedback Loops, which is a next step for the RAG approach. It is also focused on optimizing and improving the AI outputs through the cycle of feedback, and it can learn based on the production data, because mostly we see the problems now with AI, how it can handle real-time data that change continuously every day. As we know, the production data always unpredictable and changes every single time. So, and then GFL usually also can be used for creating some personalized recommendations, some targeted ads you can see on some websites, and also creating some dynamic contents. You will see a couple of examples I will show in real world use cases in which companies are using this approach. So yeah, let's break down how that works, and how we can see how GFL can improve the model output over time. So yeah, my name is Babur. I'm a DevRel at Neon, also ex-Microsoft. Nowadays, I'm Microsoft MVP for Azure AI platform. Before understanding what is a GFL, let's step back again and try to revisit what is a RAG, right? In the simple words, RAG is, it takes a user question, something like, please answer my question using the information provided to you, because you are providing context to the AI. Because usually if you're using the public GPT-4 or other existing models, they're not context aware. They don't know where you are right now and what kind of document you're processing. And usually use this model with a prompt with input data. And then these AI models can properly answer and address your questions. This is a simple like a form I put here. You can choose any model, and then you just put your question based on your provided information as input. And here the typical RAG architecture looks like. It's everywhere. You can search on the internet or ask the chat GPT. You get the same answer, like a very typical architecture. As you can see, building RAG application is also about the building RAG pipelines, right? On the left side, you can see some data storages where you want to ingest data and feed into the AI models continuously. You can get this data from Notion or Slack or maybe Google Docs or whatever, PDFs or some databases. And then because the data is usually the big, if you think about even one-page PDF, you need to usually split into more small chunks so that we can process this data one by one. Like if it's a one PDF page, you can take just one line. This is one of the approach of splitting. And then every single chunk, as you can see, we are pre-processing this data. This is a very good stage where you can filter out your privacy information before sending it to any AI models. Then, like every chunk we have, what do we do? We're gonna send and calculate a vector representation of your data using the models provided, like a very famous endpoints, like API embeddings we usually call. This embeddings model helps you to create a vector data for your input information. Input can be audio, even voice, sometimes mainly like text. So once you calculate these vector embeddings, and you're going to store these vector embeddings inside the vector storage. You can choose any vector storage, or use existing like a Postgres with additional PG extension. You can still store vector representation of the data for future use. So this is the first part of the RAG architecture, right? Next, second part comes in, like you start to build your client applications. Think about like building AI search tool that has single like search bar. You can search something. I can ask, for example, show me Adidas shoes with 42 size, which is with a discount in the market.
Bober, do you have you're not sharing anything?
Oh gosh, I wasn't sharing actually. You didn't say anything. Okay.
Sorry.
Oh my
Sorry
God.
about that.
Yeah, I was
I just
thinking.
realized you're talking to your slides and hadn't shared. There we
Oh yeah. We need to. Wow, we had a very amazing slides.
go.
Okay. I can
Take
repeat
two.
once again. Yeah.
Take two.
Yeah. Let's repeat again. Yeah. Yeah, I was saying, like we started with the RAG review. What the RAG looks like, with a single formula. We usually send the RAG, building this simple formula, sending the models, choosing the model, which model we use, and we say, hey, answer this question by using this information, which is a context. So we are just revisiting the RAG to understand like how the RAG works before we got into the GFL. So this was a typical RAG architecture I was explaining while I wasn't sharing the screen. As you can see on the left side, if you have some data stores, and usually, as I mentioned, we need to chunk this data to make it smaller size. And for every single size, we're going to calculate a vector representation of the data. As you can see on the bottom, we are using an embeddings model to calculate these data, vector data, and as a result of this, we are going to store this vector representation of the data in vector databases or vector storages. Yeah, there are a bunch of tools or services you can use as a data source or as a data destination, which is vector storage. It's up to you. Usually, the regular Postgres database also supports this. But in general, like as you can see, the first part of the RAG architecture is all about building a data pipeline, which has like a data ingestion part, pre-processing, where you can filter out some unnecessary data, vectorizing data, and storing data. Just to remember, maybe for those who are even not aware of the RAG, how the RAG architecture looks like. And this is a very introduction point. And the next, once your first part is ready, your vector data is stored in the vector databases. What do? You're going to build your AI applications front side. And think about like simple AI search tool, like you can search something on the search bar by asking the AI, show me this, or calculate for me this, or make this summary for my content, whatever in this picture your query comes in, your prompt, and you can have some backend applications that accept this prompt. And then what you do, you're going to calculate again for the question prompt vector embeddings. Because vector representation is very easy to match and find the relevant data from the vector storage we had before all the data. So and then what we do once we have a matching similar to user query and input data, we're going to get these embeddings back, and all together we will send the description of these embeddings together with user question to chat completion. The same formula I showed in the previous slide. We are saying, hey, this is a user question, this is a data we have. please give me the output. Here, the chat completion endpoint is the second famous endpoint where you can use GPT or GPT-4 models. So this is typically how the RAG architecture looks like. So next, once we understand the RAG architecture and how that works, we can turn our attention to the feedback loops. So as you can see, like a GenAI or a RAG, because the RAG also part of the GenAI primarily operates just in one-way direction, and it's generating content based on the input data we provide. But feedback loops, on the other hand, it incorporates a feedback loop with a human or without a human, where AI continuously can learn and improve from outputs it generates. For example, feedback loops originally designed in a situation where AI generates content should train over time to provide more accurate outputs. As you can see, the output of GenAI, we are sending as input to the model again. So this is a very basic principle of the feedback loops. And if you're dividing into some mechanisms of the feedback loops, there are different types of feedback loops. I have just listed here 3 possible mechanisms. Number one is feedback loops with well-trained data set, which is we are using already some from the public providers, large language models, because they're well trained. They're trained hourly or every day or maybe monthly. So you can see like in GPT, which is the latest model, a version up to which date. From that date, actually the AI cannot transfer your data. And the second one is feedback loops with a human AI interaction. Human can provide the feedback to the AI to improve its output. So third one today is our topic which is super interesting and easy to implement, feedback loops using vector stores. So let's revisit again like 2 first mechanism, and then we can start with vector store, how to implement that one, and then so that like you can understand how easy to apply these feedback loops. Feedback loops with training data sets is quite straightforward. As you can see, we have GenAI model existing. Then once we have giving and feeding the data GenAI model with more new information, GenAI model sending back to train with the new data. But in this approach, as training of new big data corpus takes a lot of time. Usually, if you use some tools, it takes like from 1 minute to some longer time to train and wait the GenAI has a more up-to-date information. This is a longer approach and more expensive. We call it also sometimes, fine tuning or training your own data set. In this approach, or even you can use nowadays Power Apps or Power Automates from Microsoft. Also, they are offering this feature. If you haven't tried, you can try it out. I can recommend it. Like it's on the preview version. For example, you can train your existing model or existing model provided by Microsoft by receiving some emails or from your SharePoint data, from your documents. You can have a more data set, so it can train over time. I had also small here demo how I trained my data, but I'm going to skip show on the first beginning, and then I'm going to skip the next. Here's how the Power, for example, Automate looks like. Without writing code, you can create some automated flows. As you can see inside the Power Automate, even in Power Apps, there is a new feature called AI models, and then AI Hub on the left side. And then you can have existing AI models already reusable. So you can, for example, extract custom data information from some documents, or you can detect some data from images and so on. And for example, if I choose one of these models and I can train my data on these models by creating some additional data sets. As you can see, I have just uploaded my rental agreement information using existing the model on the top of it. I want to train existing model on the real-time data. So in this scenario, first thing, like in the Power Apps, it's manually you need to pick the data you want to send to the AI, because AI can next time detect from your document structure what kind of data you want to extract and send to the AI. For example, I want to extract from huge document just a tenant name and then send to the AI once the tenant name changes next time. And as you can see, this after you set up what kind of data you want to extract from this GFL from this document, then you can try to retrain this data, or you can even upload multiple documents. So on. And then once you publish with existing data sets, this model, and this model can be also connected to your mailbox or SharePoint document, so that you can automate this process. So this is in general, like I'm gonna skip this demo to explore yourself, like how the SharePoint works. I can happily like provide the links here, but this is not our main topic. Let's switch to next human AI interaction, the second mechanism we are visiting. Second example is, as you can see, human on the top influences the general behavior of your AI response by rewarding the AI output if it's correct or not. Typically, you can see even in some GPT interface or other interfaces, like thumbs up and thumbs down. Thumbs up means like your answer is correct, which means AI accepts it's correct, and it's gonna reuse in the future if AI sees a typical question next time. I also created the two-in-one application using the similar approach for a logistic company, where they can run some SQL queries using natural language. So usually, a BI engineer, BI or BI analytics people, they don't know how to query data, or maybe end user, they want to use just the human language. You can convert the natural language to SQL. Here, typically, we are using natural language to SQL, but as you can see on the bottom, we have yes or no, the answer. If the generated SQL query and output data is correct, a user can click on yes, which means AI is accepting as a correct answer and the right answer for the future. But you can also manipulate as an admin of this application on the behind the scene to improve your AI output manually. So this was how the human can impact on the AI output. So third mechanism, today's very important topic is feedback loop using vector storage. This is a diagram showcases similar to GenAI diagram, but it has a bit more components and more steps, as you can see. So we have still input data coming from external data sources. What we are doing on the second step, for any data, we are if it's like longer text, we are generating summary of this text. We are shortening this long text into smaller text. And then we are saying, using the chat completion endpoint, of course. For example, I have like a 2-sentence information. I'm making it like just a 1 sentence by using chat completion endpoint. Then I'm sending to next step, which is here on the from the top, to calculate the vector embeddings from this summary. So long text is shortened, and I'm calculating vector embeddings from the long text, and I'm storing to the vector database after. But if you remember, previous approach was a little bit different, like in RAG. I was chunking, and then I was storing vector data of these chunks in the vector database directly. This time, I'm even additional to chunking, I'm even summarizing these chunks and then vectorizing and storing the vector database. Why we are doing so? Because as you can see on the right side, once like production data comes in, which is like changes always, we are doing a typical semantic search or vector search against vector database, right? Then once we are finding the matching, we are sending the output as a RAG, how it works. And then after we send the output, we are also sending the same output as an input to the next cycle. So which is the last step, as you can see in the number 10. The same output we are sending to the LLM model to improve the data continuously. So, which means now our LLM is adaptable to new data through the repeated interactions between a vector database and a large language model. So, whenever production data comes in, I can always calculate the summary and the vector data and store in vector store. So it will provide up-to-date information. Also, it reduces the bias and errors because of the first time it can answer incorrectly, but next time because it provides its output, it learns that it's the incorrect answer, can remove the bias and increase the accuracy of this model. And most importantly is personalize the model outputs. So as we are interacting with both vector stores and users, we can also learn from user preferences and provide some more personalized answers for the users of this application. Let's say a good example can be recommendation solutions in action for GFL. As you can see, AI might suggest some products to the users. For example, on Amazon website, when you go in, you can see on the top like some suggestions based on your history or browsing history, clicks or purchases. You will see some relevant products always on the top, but they use usually different technology from the machine learning, like recommendation system solutions. But this GFL also can replace these recommendation systems with a simple approach. And as user has the same like recommendation compared to machine learning approach. Even like in a real estate industry, if you think like usually like when you announce your property for selling or renting out, this listings always updates with new information such as price change always, and it has a furniture updates might happen, or availability, today is available, tomorrow is not. And GFL pipeline you build can automatically update the description of this property. For example, if one now availability is not already visible, is not available today, this listings description where you can have some like a description that user can see, user friendly, can be updated. Hey, unfortunately this property is not available right now because it's already booked or something like that. Or if you're searching for some cozy apartment in the Paris area, you can even ask AI, I want a cozy apartment next to the sea and tomorrow. So I understand this, and then it can suggest some relevant information. So other examples from real world of usage of GFL, think about like LinkedIn, for example, or all these recruitment platforms can also leverage GFL to continuously refine the job postings based on the trends that candidate search or a candidate applies with their applications. For example, AI can detect for the search if someone is searching only remote work, so more remote works can go to up, so people can see only who prefers the remote work. on the top of these job listings. Next one, for example, the same is Booking.com. All these maybe similar travel agencies can create more personalized travel itineraries for their users. For example, AI can suggest some alternative destinations, some activities. For example, if user frequently search like, I want a more adventure travel or cultural experience, the AI can prepare these itineraries, including these activities. So by aligning with the user preference always. The lastly, but not least, is Netflix. Can see dynamically, can adjust some scenes, the dialogues, even ending of the movies or TV shows based on the user viewing history or preferences or emotional responses. So this all comes with GFL use cases. So now, with enough theoretical knowledge we have, let's try something out together. So we're gonna build simple like application by applying GFL, which is like podcast recommendation application. For example, usually in podcast, you can think of every day the authors adding new podcasts, and then a user user have a specific always interest. For example, I'm interested in AI, data science, and I can see different suggestions based on the day or based on the preference I update. So we're gonna show the user some suggestions based on existing podcasts, but this podcast information updates every second, let's say. And also user preference changes. Even with Tesla cars, Tesla cars can also learn from your driving skills how automatic driver or copilot can be switched on. So here is a simple diagram how this application works. Let's say we are using Azure Functions to run my kind of REST APIs. I have three APIs here, as you can see, which is I'm implementing .NET. You will see soon, and then I'm using another serverless combination, which is Neon. It's a Postgres solution. So that everything I do is without managing infrastructure. And as you can see, we have adding podcast endpoint. Whenever podcast add a new request comes in from front end to backend API, we are calculating vector embeddings from the podcast transcription. Also, we are calculating a transcription summary. We're doing two actions, as you can see, both transcript vector embeddings and transcript summary. And we are storing the summary and the vector representation of the transcription and the Postgres database. This is what add podcast does. Then we have another endpoint. User has a profile in the application, and they can update just the history of what they prefer. Like usually when you are during the onboarding, you always be asked like which categories you would like to see this movie or to listen to this podcast. And whenever user, let's say, preference changes, I'm going to calculate simply vector embeddings from the text of the user preference, and then store into the database again. So the fancy part happens in the recommendation part of the podcast. So once I am getting some recommendation for my user Elias or Bob, first thing I need to fetch user listing history, user preferences. As you can see, I'm fetching from the Postgres database vector embeddings of this data. Then I am also at the same time fetching the most relevant podcasts. Because we had also most relevant podcast vectorized. So we're comparing vector data of the history and relevant podcast vector data. Once we are finding matching, I am generating the output simply using again chat completion endpoint by saying, hey, summarize and then make a beautiful suggestions and send back to the user. So once user receives, but here's the last step also, we are doing additional to GFL, even on the top of GFL approach. We are storing previously suggested recommendations back to the suggested podcast table. So why we need additional suggested podcast table? Because for the future improvements, for example, we want to avoid, for example, to redundant recommendations next time. We're not going to show the same recommendation we recommended previously, or we can even analyze user behavior. That's which podcasts were clicked or liked for better personalization. And then we can even refine our future recommendation algorithms for other recommendation systems, or we can even measure the performance of the recommendations, like let's say engagement rate or average similarity score. Everything can be done in this suggested podcast table for statistics, for analyzing perspective. That might be very useful. Here's a simple example. Like, as you can see, a user has a preference which has interest in deep learning, data science, trends, and then when we're going to search from bunch of podcasts, we are showing only 3 of them, which is very relevant in data science, yes, in deep learning, and like such as understanding neural networks and so on. So this is how the podcast application we are building. So now I can show this QR code. You can scan this. It will bring you to GitHub repository. After this session, you can also try this up, the GitHub code example yourself. It is very straightforward to install if you are .NET developer or whatever. I have also Python example there. So now I can change my screen and we can have a bit of coding session together. So basically, maybe I can even show when you scan this QR code, it will bring you to, let me find the report. Yep, I can go and stop the sharing and then go to my VS Code. It will bring you to a similar GitHub repository with this source code. And I opened it on my VS Code application. You can use other editors as well, which is your favorite. As you can see, I have simple .NET applications with some folders like common, data, and functions. Also, I have when you start building your application, usually start with data schema, right? What kind of data you want to store. So this is my typical data schema for my Postgres database. As you can see, I have 3 tables: podcast episodes, and I have the users table and suggested podcast, which is the third table. And usually you can also split users from the user history information. You can move to a separate table for more normalizing of the data, but you can keep it simple for the demo case. And I have some users, like 6 to 7 users who has some preferences existing. And this is all the information I have. Now, the first thing, I need to store this data into the database, right? And I'm using as fully managed Postgres. If you're like familiar with Azure or using already Azure, I can show you here. I deployed 2 services here, important service. Like one is Azure Functions, of course, for our REST API, and then I have the Neon database also deployed together with serverless functions. Both are serverless instances. You can also find the Neon database from the Azure Marketplace. Assume that I have already deployed it. This is the Azure portal where you can manage your database without running your Postgres locally or Dockerizing something. And once you have database, you can always switch to the console of your Postgres instance, and when you're creating first time like Azure instance with Neon, you will have a project with some free tier. You can use like to create you up to your first MVP or proof of concept. So you can see I have one MVP project for my GFL. And then if I click on that, without moving my console, I can interact with my Postgres. First thing first, I need to run my SQL queries, right, to create my tables and populate with the user information. Most important thing is most Postgres solutions now supporting storing vector data with the help of extensions. We call Postgres extensions. So I'm also enabling this extension in creating all these tables. There are a bunch of extensions you can use, like for rack or some other use cases. So if I run this query, everything's good. Yeah, if the extensions already exist, you will get some notification. And if I navigate to my tables tab, let's refresh. Oops, something went wrong. I don't have my tables, or I created something went wrong. Okay, let's see. All right, 5 cores went well, and we have table. Now we have a table, yes, and we have the users here. 2 other tables are empty. And as you notice here, also embeddings of user preference also empty. We're gonna calculate it in real time, this vector embeddings. So all done, the data in place. Now we can jump back to the application and then continue our development. So I can just get the connection string for .NET. I can copy the snips and put it into the Azure Functions local settings. Yeah, you can even see other like API keys and delete anyway if you want to use this after sessions. Here's like the Postgres database for Neon connection string, and other things I'm using from OpenAI is Azure OpenAI for vector embeddings endpoint, and to use also chat completion endpoint with models for completions, like GPT-4 model I'm using. For text embedding, I'm using typical ADA 002. So this is only you need a 3 important or thing the connection strings for your Azure functions. And if I open my feedback loop Azure Functions main class, which is defines everything in one, I have the same like model representation of my data, and the endpoints I was talking to you as yes, in each endpoint there's one separate function. So you can see first function is adding podcast. Here's a implementation of that. Even maybe it's better I can a bit of zoom in to make it more visible there. Yeah, here you go. This is my first function editing podcast. As you can see, what interesting part is happening here from the podcast transcription. I am calculating vector embeddings, and then from the same transcription, I am calculating the summary. And then I'm storing all together embeddings of transcription and summary into the podcast table that we created previously. What about the embedding service? Also very simple. I'm using the library, OpenAI library, also Azure OpenAI library for .NET to connect to the Azure OpenAI endpoints. And simply, I'm getting this vector embeddings also for set completions, the same. I'm connecting using the same libraries, and then by setting my prompts and saying like as my creating my just assistant generate podcast summaries. So once the podcast in place, you can think of like user preference change over time. Some people change maybe not every single day their preferences. This preference also updated automatically by the system, right? As the system calculates a number of clicks and so on. Assume that these endpoints called very frequently. So for every user history or user preferences, we are calculating the same embeddings here, and then we are storing it into users table with a listening history. Yeah, it's very simple. And the third one, which is recommending podcast implementation, as soon as like we want to recommend to user, specific user, recommend some suggestions, we are fetching that user, and we are fetching also podcast episodes by matching by comparing two vector data. As you can see, this magic operator in Postgres does this comparing of two vector data. So once we find some similarities, we are just taking a top 5 the best relevant vector data. Then we are simply sending to the chat completion endpoint to create beautiful output with the suggestions. And then we are storing suggested podcast into suggest podcast table. This is how the simple the function implementation looks like. Now, once we understand like how the structure of the code looks like, now we can try this example together. So let me create a new terminal here, and I can maybe make it a bit zoom in again, make it visible. The first thing, let's try to, I have some prepared data here. Let's try to add one podcast by sending typical curl command against my API endpoint. But first, I need to run my functions locally. Let's try to run the functions. My function is located inside I think inside the feedback loops folder, feedback loop.functions folder. Functions folder. Then I will do function start to run my function. Or you can use even a VS Code short like commands like F5 to run your Azure Functions. So here we go. It's running locally, and now the REST API is on the port 7071, is listening, and then 3 the endpoints up and running. So now it's all good. I can try to send these curl commands one by one. Let's try to add one podcast, which is the typical like podcast about something, which is long text, and I am sending it, and it should now calculate some data. Then it should come back to us. So here you go. Yeah, podcast about the future of robotics added successfully. The rest is not important. I think the curl command mistake. So we can validate this data addition by switching back to our database. So let's see if the podcast added successfully. If I go to podcast episode, here we go. As you can see, we have the podcast and podcast summary, also generated by the AI. And then transcription is transcription we send. And then embeddings are calculated. This is embeddings, the vector data is in place. All good. So next, I'm gonna try to update the user preference from to something. Let's say user with ID 1, Alice, user history changed, and now she's interested in robotics and AI. So I'm gonna send second curl command and try it. Yes, now the user's listening history updated. I can validate later, or I can see now, because the interesting part here for the existing user, we now for the future preference changes, we are changing, calculating vector embeddings and storing it here. So here, vector data also there, and now the last curl command, the most fancy part of this finding recommendations for this user. Of course, now you can say, hey, Bob, we have only one podcast in the database. Yes, and now we will get only one. But in reality, you can have thousands of them, and it doesn't matter uh, because the mechanism works quite fast thanks to the vector data, thanks to the RAG approach and GFL approach we're doing. Only difference is once you connect all these three endpoints to production environment, podcast can change, user preference can change, but the recommendation podcast also changes and also provides more relevant, up-to-date information. You can see also some similarity score, how much close the recommendations is found. So, or even you can connect to the real the podcast API and try it out. It should work in real world scenarios. This is how this works. Next, like once I have my Azure Functions development is ready, and then I have a database is ready, I can now deploy my Azure function to the cloud. I can so that I can also start to use in the production environment. So to do so, let me maybe open another terminal. Then I will try to deploy my function to Azure Cloud. I think feedback loops functions, and another command I'm going to run now. Function Azure Function App published that publish new functions to the Function App. Let me check what was the name of the Azure Functions. You can switch back to my Azure Functions. It's called GFL dash demo. This is my Function App. I think I deployed also previously these Azure Functions, but I can try to redeploy them again. Like I'm going to put here GFL demo and run. Depending on like how much data you change, it should be quick because usually actually I haven't changed like much stuff since the previous deployment of my Azure Functions, so it should be quite fast. Once the deployment is ready, you can also go to the production ready Azure Functions, or thing is, you can update the environment variables that we used locally, or you can maybe run through the CI/CD pipeline and set the connection string securely into the function apps. So that was kind of demo part. We can maybe wait until deployment and try it out while its deployment is going. I can talk about a bit of additional thing. Just a moment. So let me share my slides again. So yeah, this is the application we implemented just now. And so shortly, like about the Azure function, we know the serverless. I also use the Neon because of the purposes was it's first of all like it's free to start. Also, it has a very great the feature called the branching, database branching, where you can create a different version of your data as for dev, staging, and production. The same way, if I'm testing new models, new approach for my GFL, I can test it on dev environment. If everything's great, as we are managing data in Git, you can deploy it into the production branch. So in terms of like, let's think about like podcasts are growing, and then you will have a bunch of podcasts, and then you have the data storage huge. It can scale automatically, so you don't have to worry about the scaling part. This is like how the serverless combination of Azure Functions and Neon works together. So there are other like demos. Also, I prepared. If you are interested, I can also drop the links in the chat for more AI agentic use cases or AI agents. Or there is another report for building your own RAG applications using the Azure services. So I think the deployment is done. Yes, here we go. So deployment was successful, and you can go to Azure portal and test the Azure Functions easily. So I think we can do a bit of testing, but it takes a bit of time to update the environment variables. We can skip that part. So let's maybe switch back to the slides again. So now, since like we are running out of time, like I have 10 minutes more, we can stop here, first concentrate if everybody, maybe some people have the questions, we can try to address these questions. Let me check the chat.
I don't see any questions in the chat, so
Okay.
nobody's posted that.
In the comments. Now I can see. Okay, cool.
Yeah, the public comments. Yeah. Nobody has posted anything, so no questions. But thank you very much for a very interactive and informative session. So great to see these technologies working firsthand and deploying and all those things. So thank you very much for that.
Thank you for inviting. By the way, at the beginning, there was a bit of first 2 minutes I was saying, I'm sharing my screen and I'm speaking.
Yep, no problem. No worries. I didn't realize that you had gone beyond that. I was sorry, I got distracted too, where I would have grabbed you quicker. But we worked it out. We still came in within the hour, so no worries there. But yeah, thanks everybody for your attendance to this Cloud Lunch and Learn session. We have these sessions on a regular basis. Continue to look at cloudlunchlearn.com for upcoming sessions. You can also go to the Cloud Lunch and Learn YouTube channel to see the recording of this as well as other sessions as well. So thank you very much. Thank you, Bober, and we look forward to seeing you on a future session as well. So have a great day, everybody, and always be learning. Continue on. Thank you.
Thanks so much. Yeah.